Algebra word problems number 27b, write, solve linear equations part 2. I hope you saw the first one, 27a, the first part of my linear equations word problem video. A linear equation has two variables where each variable has an exponent of 1. So remember, an exponent of 1 is usually not written. It's like an invisible 1 in front of the variable, okay? And we don't need a 1 there to tell us that there's 1y. We can see there's 1y without the 1 there. We just don't write it. So y equals 2x plus 3 is a linear equation that has two variables, x and y. And they have more than one solution. Each solution has two parts, an x value and a y value. And for each value of x, there's a matching value of y. So take a look at this. We have a table of values here. And this keeps all of our answers in a nice, neat little place in a nice, neat little table. Y equals 2x plus 3. We plug the value of x into the equation, and we get the value of y. So if the value of x was 2, that means 2 times 2 is 4, plus 3 is 7. So the value of y is 7. And if x was 3, 2 times 3 is 6, plus 3 is 9. The value of y is 9. And if the value of x was 4, 2 times 4 is 8, plus 3, the value of y is 11. See? So by having the values of x, we can get the value of y. And by having the value of y, we can get the value of x. This is why. This is how. If we have the value of y, we can find x. Okay? If y is 21, what would x be? All right, so let's say 21 equals 2x plus 3, because that's where the y was, right? So we're going to put the 21 there. So because this is a plus 3, to do an inverse operation, we want to get this x by itself. We're going to subtract 3 from each side of the equal sign, and that's going to create a 0 pair. If you have 3 and you take away 3, it's 0. So that falls off. We discard it. And 21 minus 3 is 18. So now we just drop down the 2x, and we have 18 equals 2x. Because 2x means 2 times x, 2 multiplied to x, the inverse operation to get rid of this 2 to get the x by itself would be division. So we divide both sides of the equal sign by 2. 2 divided by 2 creates a 1. There's our invisible 1 that's in front of our variable, so we can just throw that 2 over 2 away, and 18 divided by 2 is 9. We know that x equals 9, see? So just remember, any inverse operation done on the left side of the equal sign needs to be done on the right side of the equal sign, and vice versa. We need to maintain the balance like it's a scale. What we do to one, we do to the other, okay? So take a look at this. It says, write a linear equation that tells the perimeter P of the rectangle below. So we think of the problem we just did in video number 27a. I hope you saw it. But if you didn't, it's okay. We'll continue. It says to write an equation that tells the perimeter. So it wants us to find the perimeter. So we know we've got P equals. We know we've got that much so far, because that means the perimeter equals. All right? So we know also that perimeters go all the way around. The perimeter of a rectangle goes all the way around the rectangle. So that means it includes all the sides. So now we need an equation that includes every single one of these sides. So we end up with 2L's plus 8 is going to equal the P, isn't it? Now we can make a table of values. With this equation, if L is 5, that means 2 times 5 is 10, plus 8, then P would be 18. And if L was 6, 2 times 6 is 12, plus 8, that means P would be 20. And if L was 7, 2 times 7 is 14, plus 8, that means P would be 22. See? We'd be able to figure out our table of values and know all of our variables of what they could be. See? All right, let's try this one. Tala sold earrings at a booth at a county fair, and her cost to make each pair was $1.25. And she sold them for $9.95. So she paid $120 to rent the booth at the fair. So write an equation to show her profit, P, if she sells N pairs of earrings. So we know we've got profit, P, is what we're looking for. So we know we've got P equals, all right, or equals P. We know we've got that much so far. We don't know the amount of earrings she sold, so we could probably make a table of values to show all the different profits that she could have made depending on how many she sold. So we need to subtract her cost from her selling price. This was her cost, and this was her selling price. We can find out the profit for each separate pair of earrings that she sells. So $9.95 minus $125, she made $8.70 for every pair she sold. Okay? Well, once we have the profit for each pair, we have to multiply that amount by the pairs she sold. And we said that she sells n pairs, so that means that this amount is going to be multiplied by n, the 870 by n. But the amount she paid for the booth has to be subtracted from the sales of all the earrings she sold that day, because that's part of her cost too. So now, after the n, we write minus 120. See? So we have our equation, and we can make a table of values to find how many pairs of earrings she needs to sell to cover the cost of the booth. All right, so that's a big amount that she has to cover at $870 for each pair of earrings. If she sells one pair of earrings, she's still going to be in the negative $111.30 for paying for the booth, because that's only $870. That's not going to cover the cost of the booth, the $120. If she sells 10 pairs, she's still going to be negative by $32.90. She hasn't sold enough. If she sells 13 pairs, she's still negative by $6.90 to cover the cost of the booth. But once she sells 14 pairs of earrings, she'll make a profit of $1.80. And the booth cost of $120 will be covered. See, what I did was I multiplied times 10 and got $87.10, and I subtracted that from the 120 to get $32.90. See? I did it for each one. So I realized that she needs to sell 14 pair of earrings before she's even really going to start to make a profit to cover the cost of that booth. See? And then after that, it's all extra for her, okay? I'm going to make one more video, 27C, that's going to have an example of linear equations and word problems and how to do them. It's going to be one more problem. If you feel like you've got this, you can move on to the next video, 28B, to the next 28, I'm sorry, for the next topic. And if you would like to see the next example, I'll see you at 27C. Bye.